Okay, so in this video, we're given a bunch of information about definite integrals, and we're asked to evaluate the given definite integrals. So the first bit of information we're given is the definite integral from 0 to 4 of f of x dx equals the number 3. We're given that 0 to 4 of g of x dx is equal to 2. So what's the difference between those two? This is the f function, this is the g function. We're also given the integral from 0 to 7 of f gives you 4 or 7, and then the integral from 4 to 8 of g of x gets you negative 3. Okay, so just random bits of information seemingly, and I want you to calculate first the integral of f plus g of x dx from 0 to 4. So whenever I see a plus here, I start thinking automatically I'm going to divide and conquer. So I'm going to split this up into two integrals. The first one, the integral from 0 to 4 f of x dx. And then the second one, I put a plus in between the two, integral from 0 to 4 g of x dx. Now why is this useful? Because I know that this right here is equal to 3. And I know that this right here is equal to 2. So I can substitute 3 plus 2 in for my definite integrals, and I get 5. Let's try another one. So I've got the integral from 0 to 4 again. So guess what? I'm probably going to be using these. And the difference here is that now it looks like I have constants in here. So a 5 and a negative 7. So I'm going to use the constant multiple rule after I split this up on the negative parts. Ooh, that should be a minus here. Oh no, wait. Okay, never mind. That's okay. I have a negative here. So a negative 7. I'm just adding a negative 7. That's perfectly fine. All right. So now what do I need to do? Well, I need to factor out. I need to pull this constant out here. So I pull the 5 out front. And then here, I need to pull the negative 7 out front. So I'm going to pull a negative 7 out front. So now I have what? I have the integral from 0 to 4 f of x dx, which I know is 3. And then I have the integral from 0 to 4 g of x dx, which I know to be 2. So I'm going to replace those integrals with 3 and 2 for those. It's going to produce 15 minus 14, which gets you 1. Okay? So the trick is to somehow make whatever the thing you're trying to evaluate, the definite integral you're evaluating, to look like the information that you are given. Okay? Otherwise, you're going to have to use properties from definite integrals in that video previous to this. Okay? So this integral here is from 0 to 8. I'm going to look and see if I've got anything from 0 to 8. Looks like I have a g of x here and here, but I don't have anything from 0 to 8. But what I do have is from 0 to 4, and then from 4 to 8. So what do I know about limits of integration? Well, if they break and stop at the same point, then I can put those two together, and then it will integrate from 0 to 8 automatically. Okay, so that's the goal. That's the game plan. I'm going to take this integral. I'm going to split it into two integrals, one of them from 0 to 4, and then I'm going to add it to the other one from 4 to 8. And so now I'm integrating from 0 to 8 via two integrals. And the benefit to this is I know that this integral is equal to 2. And I know that this integral is equal to negative 3. So whenever I add 2 and negative 3, I get negative 1 for my answer. Not bad. For this last one here, I have the integral from 4 to 7 of f of x dx. So I'm looking at functions that have f together. This one goes from 0 to 4. This one goes from 0 to 7. I don't see anything that goes from 4 to 7. So I need to think about this, and maybe drawing a picture will help you. So I don't know what f or g look like, but I can like kind of just do a rough drawing here, okay? I know that f of x integrated is positive. It's a positive output, so I know it's above the x-axis like that. And so what do I know? From 0 to 4, it's 3. So from 0 to 4, and then I get some positive area of 3 here. Okay. And then the other one is from 0 to 7. And so from 0 to 7, I have an area of, I guess, 7. So let me do dark here for this. And then I'm going to do green here for the 7. And I'm going to highlight the green all the way across here so we can see that that's all of it. Okay? So how in the world am I going to get this area from 4 to 7, which is only this piece here? Well, if I know that the whole thing is 7, okay, that's not a good color. Okay, the whole thing is 7, and then I don't want this piece, so I subtract off that piece. That's going to get me this sub piece right here, which is 4. Okay, so how do I write that out without having that picture there? Okay, so what does this look like? This is equal to the integral from 0 to 7, okay, 0 to 7 f of x dx, minus the integral from 0 to 4. Sorry, I highlighted the wrong one, f of x dx. Okay, now why do I subtract? Well, if you think about it just for a second, so we go from 0 to 4 to 7. So the integral from 0 to 7 gets all this stuff right here. Okay? But the problem is the only thing that we want is this piece right here. So that's from here to here. So what we have to do is we have to somehow cut out this area here. What is that area there? That area there is from 0 to 4 of f of x dx, right? So how do I cut it out? I subtract it away, okay? And so that's what I'm doing whenever I'm subtracting here. When I'm subtracting that away, that's what's happening right there. And so that result is going to be what I wanted right here, okay? So this is equal to 7 minus 3, which gets you 4. All right, so very important that you understand these concepts. I'm probably going to throw several of these types of problems at you just because it's not something you can just type in your calculator and get the answer. You need to understand the concepts of the definite integral properties, these properties right here, in order to be able to work those problems.